which is this part. If I ask for the loss in kinetic energy, what you have to do? This. The whole thing. If I ask what is the fractional loss, what is the meaning of fractional loss? Fractional loss. So what is the loss? This. Fraction out of what? Usually you take the out of what, the fraction? If it's fractional loss, out of the total, at what time? Beginning or end? Then if it's a fractional loss, is at the beginning. It's like the fractional loss. K initial. This is what if they ask for the fractional loss. So they can ask here for the total energy, before or after. They can ask for the loss of kinetic energy, or they can ask for the fractional loss, which is the total over the initial. This is the initial. The change, so the change over this, that will be the fractional loss. Any question? Good. These are typical questions in an inelastic collision. So the two objects collide, I will ask for the velocity after the collision, and then I can ask also for the loss of energy, or fractional loss, or the total energy at the end. Any question like that? Good. This is this type of question. Also, we will have question in inelastic collision, inelastic, where we combine energy and linear momentum. Example. One typical example is an example which is called ballistic pendulum. Ballistic pendulum. What is a ballistic pendulum? A ballistic pendulum is a device that we use to find the initial speed of a projectile, like a bullet. So let's say that I put a pendulum like this, a cord hanging from two cord and one block here, large block here, hanging. And then I will shoot a bullet that can either transpass or get embedded. For this instance, I will say that will get embedded. So you shoot and this get embedded on the large block. This will swing as a pendulum up. Like this. And the projectile, which is embedded, because didn't transpass, will move like this. So this is not drawn to the skirt, the block. The question is, if I give information on the pendulum, like the height, the angle, and the length of the cord, either one, with that information of the height from the lowest point, what is the height, or what is the angle and the cord, which I can get the height. How do we get the height when we have the length of the cord and the angle? There was a formula that I said last week in order to find the height y. L times what? So y will be L times 1 minus cosine theta if the angle is the angle from the vertical. This. Good. Now, if I give the mass of this projectile, which I will label as a lowercase m, the mass of the bullet, typical, the mass of the bullet have to be of less mass than the mass of the block. And the mass of the block, I will put it as capital M. I can ask, what will be the velocity of the projectile? For instance, let's say that the height here, or the height or the length is 1.5 meter. Theta, I can say that is, let's say, 20 degrees. The question will be find the initial speed of the bullet, which the initial speed of the bullet I will label as u. How can I change the design? Very simple. You can place a ramp, you can place a block here, and you can shoot a bullet here. The bullet get embedded and will move as a pendulum to here, and this is the bullet, and I give this height. Is that the same type of problem? Without friction? Assuming that the block is going without friction. It's the same type of problem. So this is what we call ballistic pendulum. So these are designs that we use to measure the speed of the bullet. So here we have a connection of two topics. What are the two topics? When a bullet hit a block, what is that topic in physics? Collision. And collision is related to what topic? How is called that topic in physics? The topic that covers collision. Linear momentum. So we know that during the collision, what happens is that the momentum conserves. And then the pendulum, once this gets embedded, the pendulum swings up. Where we study the swinging of a pendulum, in what topic of physics? Where was the first time that I talked here so far? Energy. So, from here, energy. And what type of energy conservation? Theorem 1, 2, or 3? The third, which was EI is equally final. You remember that? Yes. So, combining these two topics, momentum, the collision, and energy swinging, we can't solve the problem. So, how can we solve the problem? Let's start. You start from what we are looking for. In physics, you start solving the problem from what we are looking for. And if we need an extra information, we will go and find it. So, here you told me that this up to here is collision. In that part, we will use the law of conservation of linear momentum. And in this part, we will use what conservation law? In this part, EI is equally final. That's it. So, since we are looking for U, from which topic we start? We are looking for U initial.